Hi there, it's Mrs. Trombley yet again. I know you're probably tired of my voice, but we're almost there. We're wrapping it up. We're finishing all the different ways to solve quadratics today. So 9-4, we're finally here. We're using the quadratic formula, and hopefully you have listened to the song on the website or listened to some songs of your own, looked them up on YouTube, or maybe you even made up one yourself for how to memorize this thing. Yup. So the final way we're going to learn is to use a quadratic formula. And the real solutions of the quadratic equation ax squared plus bx plus c equals 0 can be found using this. And in this, just like always, a can't be 0 because if a is 0, we don't have a parabola. And the b squared minus 4ac, this little part in here, needs to be greater than or equal to 0. Because if this little part that I'm taking the square root of is less than 0, wouldn't that make it the square root of a negative? And is that possible? No. All right, so this little portion right here, the b squared minus 4ac, that's called the discriminant. All right, so basically what we're going to do is we're going to look at how to use the discriminant to tell us how many solutions there are. And then we're going to plug some of these things into the quadratic formula. Now, when we were talking about the other methods, there are certain scenarios that would force you into using the other methods, or it could give you the option, I guess, of using the other methods. The quadratic formula works no matter what. So no matter what form the equation is written in, this can be your go-to. This could be the one. So if you don't like any of the methods that you have learned so far, which I hope you like some of them, they're not that bad. But this one, yeah, this is my personal favorite because I like when things work like a charm. I like when things work every single time, and this will. So that's why if you haven't memorized this formula yet, it'd be a good idea because this will be your go-to. Okay, and it says x equals here, just side note, because that's what the solutions are, right? They're the values of x when y is 0. They're the intercepts, the zeros, the roots, all those different words. Okay, so the b squared minus 4ac part of this formula. That expression is called the discriminant, and you can use it to determine if there's going to be 2 real solutions, 1 real solution, or no real solutions, NRS. So here's how you can tell. If this little portion here is positive, that means I'm going to have a positive and negative version of what's inside. I'm going to end up with 2 solutions. If b squared minus 4ac equals 0, that means I'm going to have 1 solution, because when I go to do the positive or negative of 0, there's not a positive or negative of 0, it's just 0, right? So that eliminates this whole part, and you're left with 1 solution. If b squared minus 4ac is negative, that means I'm not going to have any solutions. I can stop there, because if this is negative, it's impossible to take the square root of a negative. All right, so that's basically today when we use the quadratic formula. We'll end up calculating the discriminant first every single time so we know what we're dealing with, and so that we're not wasting time if there aren't any solutions. Okay. So right here, 3x squared plus 10x plus 2, I want to show you an example of what it means when there are 2 real solutions. So all you're going to do to calculate the discriminant is you need to identify your a, b, and c. So in this case, a is 3, b is 10, c is 2. Then yeah, it has to be in standard form in order to identify your a, b, c. Then we're just going to plug those values into the b squared minus 4ac. So b is a positive 10, so I don't need to wrap it up in parentheses, it's positive 10. And I want to subtract 4 times a times c. Now if you want, you can go ahead, you can type that whole stream of numbers in your calculator. For this one, I'm probably not going to, because I know 10 squared is 100, and I have to do all this multiplication before I can subtract. So 4 times 3 is 12, 12 times 2 is 24, 100 minus 24 is 76. Now I'm not asking you for the solutions, I'm just asking you how many. I just got for the discriminant a positive 76. That means that there are 2 real solutions because the discriminant is equal to a number that's greater than 0. Now this is how I'll be able to tell if there's 1 real solution. I'm going to keep change this. Identify your a, your b is a negative 6, and your c. And we're going to plug it into b squared minus 4ac. So this time b is negative 6. I'm going to put parentheses around it, so I'm squaring the negative with it. And I want to subtract 4 times a times c. Now last time I didn't keep change. You can. It's not going to affect your answer at all. It's okay. Negative 6, the quantity of negative 6 squared is 36. And I need to do all that before I add. Negative 4 times 9 is negative 36 times 1 is negative 36. When I add those, I get 0. So if the discriminant is equal to 0, right now, that means that I'm going to have just one solution. So one real solution. Because remember I told you before, there are imaginary ones. Yep, and I wasn't making that up. Alright, now how to recognize if you're going to have no real solutions. Identify your A, your B, your C. Plug it into b squared minus 4ac. So I have 1 squared, and I'll change this to plus negative. Plus negative 4 times 1 times 1. So 1 plus negative 4 is negative 3. If you get a negative amount for your discriminant, you're supposed to take the square root of that in the formula. It's not possible, so this would be no real solutions. Or I said before, you can say NRS. We've said that enough now, I think, for you to know what it means. So I don't mind if you abbreviate, that's good. All right, so one little portion of what I'm going to ask you to do for your classwork is determine how many solutions there are to each equation. If I ask you how many there are, I'm not asking you to solve it. I'm just asking you to tell me, are there 2, 1, or none? Okay? So in order to figure this out, it has to be in standard form so you can identify ABC. So let's do that first. Let's get this 3 on this side. So you'll have 2x squared minus 2x plus 3 equals 0. And I'll keep change it, because I know a lot of us do. It's a great little strategy. All right, identify your A, your B, and your C. It's as easy as 1, 2, 3. Oldie but a goodie song, never goes away. Okay, so I'm going to take b squared minus 4ac, that's the discriminant. And b is negative, so I'm going to be sure to wrap that up in parentheses so I know I'm taking the negative base. And I want to take 4 times a is 2, and b is 3. All right, with this one I would end up with the quantity of negative 2 squared is 4. And I'll keep change, why not? Negative 4 times 2 is negative 8. Negative 8 times 3, negative 24. And when you take 4 plus negative 24, yeah, you're going to get negative 20. Remember, if your discriminant is negative, that means no real solutions. So this one's going to have 0 real solutions to it because the discriminant is a negative. All right, moving on over. This again, this isn't in standard form. So to make time go back, I don't know what I'm talking about. To save time, I want this negative 4 over there instead of moving those two terms. So I would add 4. So I get 0 equals x squared plus 4x plus 4. Now that it's in standard form, I identify my A, my B, my C. Again, it's still as easy as 1, 2, 3. I have to say it every time. I know I can't help it. All right, so I'm going to plug that into b squared minus 4ac, or b squared plus negative 4ac, whatever you like. And b is a positive 4, a is 1, c is 4. All right, 4 squared is 16. Negative 4 times 1 times 4 is a negative 16. And when you take 16 plus negative 16, you get 0. When you get 0, that doesn't mean there aren't any solutions. It means there's one real solution. Because it is possible to take the square root of 0. It's 0. It's not possible to take the square root of a negative, though. So when you get 0 for your discriminant, that means there's one real solution because there's not a positive and a negative version of 0. All right, with this last one, the choice is yours. You can move this over there. You can move these over here. I'm just going to move them over to this side because I like my x's positive. Everybody likes friendly x's. Yep. Otherwise, it's just awkward. Anyway, maybe you're laughing. Maybe you're like, oh, just get over it. All right. So I'm going to subtract 9x. I'm going to add positive 4. I'm going to do this to both sides. So you end up with x squared plus negative 9x plus 4 equals 0. Now I can identify my A, my B, my C. If you did move the x squared, just so you know, you're still going to get the same thing. You're going to get what you need to get. All right, so b squared minus 4ac. I have negative 9 squared minus 4 times 1 times 4. The quantity of negative 9 squared is 81. And 4 times 4 is 16. And when you take 81 minus 16, you get 65. That's not the answer. That just tells me, hey, there are two answers because the discriminant is greater than 0. So 2 real solutions. All right, we're not done. I know, seems crazy, but we're halfway there. All right, turn your page. Now we actually get to use this quadratic formula. And I realize that you could go ahead and you could try to find these values and plug it all into 1 and do it all at one time, but I'm telling you from experience that's where little mistakes happen. So what I'm going to recommend that you do when you're using this formula, because all you need, you're still finding ABC and you're just kind of plugging all this stuff in. After you make sure it's in standard form and locate your ABC, I'm recommending you calculate the discriminant first and then put the discriminant into the formula. Okay, you'll see what I mean in just a moment. So I've just found that that's the way that you're least likely to make mistakes. So these steps are listed right here. I'll kind of talk through them even though you can't see them up on the screen. I know you can see them on your paper. All right, so solve each using the quadratic formula. Yes, I could try to complete the square. I could try to graph this. I could do whatever I want. There's all kinds of different ways, but today we're focusing on the quadratic formula way. Okay, so step 1, standard form, done. Step 2, identify ABC. So I'm going to keep change. A is 2, B is -5, C is 3. Okay, so we've got our ABC. Step 3 says calculate the discriminant to determine the number of solutions. So right now, I'm going to do the B squared minus 4AC. That's what I'm going to calculate out. So B is -5, A is 2, C is 3. So I'll shortcut it now. You can go ahead and type all that in. You'd end up getting 25 minus 24. It gives you 1. So right now I can tell because that's greater than 0, I'm going to get 2 solutions. So I know that this number right here is my discriminant. In the quadratic formula, it says that x is equal to the opposite of b plus or minus what we just found out divided by 2a. So if x equals opposite of b, we just had that b was -5, right? What's the opposite of -5? It's 5. So opposite b, and now plus or minus b squared minus 4ac. So I'm going to write plus or minus the square root of b squared minus 4ac, which we just figured out was 1. So I'm just replacing what's underneath there. I'm sorry if I'm giving you like motion sickness. We just replaced b squared minus 4ac with the number that we found. We still have to take the square root of it. And we're supposed to divide that by 2 times a. So in the denominator, I'm going to put 2 times, and a is 2. Okay. So basically there's 2 solutions, right? X can be equal to 5 plus the square root of 1 divided by, and 2 times 2 is 4. Or x can be equal to 5 minus the square root of 1 divided by 4. So what is the square root of 1? It's 1. If you didn't know that, you'd hit second x squared 1, but 1 times 1 is 1, yes. So I'm going to take the positive version of that, and I want to divide that by 2 times 2, which is 4. X can also be equal to 5 minus the square root of 1, which is 1, divided by 4. So now all that's left to do to figure out our answers is simplify this. So 5 plus 1 is 6. 6 divided by 4 is 1.5. There's one answer. 5 minus 1 is 4. 4 divided by 4 is 1. That's my other answer. So there. That's how you use this. Let's try another one. I know, again, these are things that are going to come with time. You just need to practice. Okay, in this one, I'm hoping that you notice they're not all on one side. So the first thing you should do is put this in standard form. So you end up with 4x squared plus 20x plus 25 equals 0. That's your standard form. And now we can identify our ABC. I'm just going to write it up over here. A is 4, B is 20, C is 25. And I can't factor anything out. There's not a number that will go into all 3 of those. So yes, they're big numbers, but we got to deal with it. I'm sorry. Okay, so standard form, identified our ABC. Step number 3 says, find the discriminant. So I'm going to take b squared minus 4ac. So 20 squared minus 4 times A times C. When you take 20 squared minus 4 times 4 times 25, well, 20 squared minus 4 times 4 times 25 gives you nothing. We get 0. That doesn't mean that there are 0 solutions. It means that there's one solution, right? Because when you take the square root of 0, there's not a positive or negative version of it. So after you found your discriminant, we're now going to put it into the quadratic formula. So in the quadratic formula, x is equal to the opposite of b, so b is 20, now it's negative 20, plus or minus the square root of b squared minus 4ac, which we said was 0, divided by 2 times a. Hopefully you're with me. So opposite of b plus or minus the square root of the discriminant divided by 2 times a. Now for this one, x equals negative 20, and square root of 0 is 0, right? So whether it's plus 0 or minus 0, it's just negative 20, isn't it? And I want to divide that by 2 times 4 is 8. So all that's left to do is simplify this. Negative 20 divided by 8 is negative 2.5. There's just one solution because there's not a positive or negative version of 0. Again, if I would have written negative 20 plus 0 over 8 and negative 20 minus 0 over 8, wouldn't I still get the same exact thing? Yes. So it's not necessary to write that. If it helps you to write it because you're used to solving it out that way, I don't have a problem with it, but it's unnecessary. All right, let's do another one. We got 2 left. I need all of these over here because it needs to be standard form. So I'm going to add 4. So I have negative 5x squared plus x plus 4 equals 0. Nothing to factor out. A is negative 5. B, when I don't see a number in front of the x, it means it's 1. And C is 4. So I identified our ABC, standard form, ABC. Now I want to do b squared minus 4ac, the discriminant. So b is 1 minus 4 times a is negative 5, c is 4. When you solve that out, you end up getting, and you might think, oh, it's negative, but it's really not, because this is going to end up being positive because a negative times a negative are positive. So when you do this, you end up getting negative 4 times negative 5 is 20, 20 times 4 is 80, 1 plus 80 is 81. So we're going to end up with 2 real solutions because our discriminant is greater than 0. Alright, so after this we want to go back to the formula. X equals opposite b plus or minus the square root of the discriminant divided by 2 times a. And if you're looking back at that formula each time, it's okay. Eventually it's just going to stick in your head. Like every time I do it, I hear the song x equals opposite b plus or minus the root of, you know the song. So having that song helps me every single time to plug that formula in correctly, in the right way. Incorrectly sounds like I'm doing it wrong, but you know what I mean. So have something, have a little song in your head, do whatever it takes. Alright, so x can be equal to negative 1 plus the square root of 81, a nice exact number, it's 9, divided by 2 times negative 5 is negative 10. X can also be equal to negative 1 minus the square root of 81 over negative 10. So now we're just going to simplify these. Negative 1 plus 9 is 8, and 8 divided by negative 10 is negative 8/10. Negative 1 plus negative 9 is negative 10, and negative 10 divided by itself is 1. So now we have our 2 answers. Alright, 1 left. I know. I'm so excited. Alright, I'm going to get this in standard form first because that's step 1. 6x squared plus 2x plus 1 equals 0. Nothing to factor out, so leave it like it is. Identify your A, your B, your C. Calculate the discriminant. B squared minus 4 times A times C. So when you take 4 minus 24, you get negative 20. Guess what? There aren't any solutions. You don't need to go any further. You don't have to plug anything in. If you see that the discriminant is a negative, that means there aren't going to be any solutions to this. No real solutions. So you've learned how to solve a quadratic by factoring. You've learned how to solve a quadratic by completing the square, by graphing, by using square roots, and by using the quadratic formula. You can use any method you want. Don't discriminate. I mean discriminate. Use whatever formula works best for you. Ha ha ha. I'll see you tomorrow.